What is a transfer function? A transfer function is an S-domain concept. It's really two things. It's a ratio of two S-domain signals, and at the same time, it's an S-domain output-input ratio of a linear system. What is a signal? Voltage and current are common in electrical engineering. Position, velocity, acceleration, pressure, temperature, humidity, and many more in mechanical engineering. These are all time domain signals that are common in electrical engineering and mechanical engineering. The Laplace transform of these time domain signals can be derived, and then one S-domain signal can be divided into another to form a ratio. That's a transfer function. This block diagram shows two signals, F1 and F2. Both are functions of S, which represent time domain functions. The output signal must be in the numerator, and the input signal must be in the denominator. The transfer function is the output signal divided by the input signal. In addition, the transfer function is all about the linear system and has nothing to do with the specific input and output signals. The transfer function g and the transfer function f2 over f1 are equal to each other, even though they are totally independent of each other. Here is a familiar example: 12-volt battery in series with a switch that closes at t equals 0, in series with a 5-ohm resistor and a 2 farad capacitor. Time constant is 10 seconds. Determine the voltage across the capacitor as a function of time. The capacitor voltage rises exponentially up to 12 volts with a time constant of 10 seconds. This is the time domain input signal V1. This is the time domain output signal V2. The input signal, both in the time domain and S domain, the output signal in the time domain and S domain. Divide the output signal by the input signal. Simplify. Denominator divides into the numerator. Form a common denominator and simplify. That's standard polynomial form, and that's the transfer function based on the output and input signals. Derive the transfer function given the system parameters. Ignore both input and output signals. The input signal has been removed and replaced with the variable V1. Take the Laplace transform of all system parameters. Use the voltage divider rule. Multiply top and bottom by 2s. Divide top and bottom by 10. Put in standard polynomial form, which is the resulting transfer function based on system parameters, and which is the same as the transfer function derived from input and output signals. In summary, the transfer function is the output signal divided by the input signal, and also the transfer function can be about the linear system that has nothing to do with the specific input and output signals. Since the system parameters and the I/O signals have been separated, some amazing things can be done with transfer functions.